This is section 15.5 on surface area. Should be a fairly straightforward section. So not that bad at all. All right, so page 1026. If you have a function, z is a function of x and y over some region, what is the surface area of this thing here? Okay, so we analyze just one plot as normal. We just think of what happens from one plot and then do the same thing for all the other plots, as it were. So figure 2 is the picture that we want to have in mind. So here's a delta x and a delta y giving me a delta A change in area. So what is this surface area up here? Well, if I can find out the vector A and the vector B, they form a parallelogram. And you might recall that the magnitude of the cross product gives me the area of that parallelogram. And then I can apply that to not only this piece, but all the other pieces that I decide to chop up in both the x and y directions. So they did A cross B, which is composed of delta x, 0, and fx delta x, and 0 delta y, fy delta y. It comes out to be negative fx, negative fy, and 1, whose magnitude is the square root of fx squared plus fy squared plus 1. And that pretty much gives it to you. That pretty much gives you the formula. So you just sum over all of them, and you end up integrating that thing. So in a nutshell, this is what you want to put on your formula sheet. Surface area, double integral of square root of fx squared plus fy squared plus 1 dA. Or you can also think of it like so. It's the same thing. Surface area is a double integral of the square root of 1 plus z sub x squared plus z sub y squared dA. And a side note, you notice the similarity between the arc length formula. The arc length formula in Calc 2 was integral of 1 plus dy dx squared dx. Okay, so here you have dz dx squared and just put dz dy squared, or actually the partial of z with respect to x and partial z with respect to y squared. Notice the similarity there. Okay, so that's basically it. You're just integrating stuff that looks like this. So this one's not too bad. Here's 1028. And here we go. The main thing for a lot of these is they don't give it to you as z is a function of x and y. You have to make it look like z is a function of x and y. Okay, and so here we go. Okay, and a side reminder. So the double integral of dA is A, triple integral of dV is V, single integral of dx is just a length. So 1 dimension, 2 dimensions, 3 dimensions for some of these integrals. All right, so this is a plane 5x plus 3y minus z plus 6 equals 0 from 1, 4 cross 2, 6. Of course, that means x goes from 1 to 4, y goes from 2 to 6. So first you have to solve for z. Put the z over, so z equals 5x plus 3y plus 6. So I need z sub x, 5, z sub y, 3. So the surface area is a double integral as x goes from 1 to 4, y goes from 2 to 6 of 1 plus z sub x squared, 5 squared, 25, plus z sub y squared, 3 squared is 9. This is a constant, so that's going to be radical 35 dA. Double integral of dA is just A, so it's just the area. Radical 35 from 1 to 4, that's 3. 2 to 6 is 4. 3 times 4, 12 radical 35. Number 3, 3x plus 2y plus z equals 6. First octant view. So solve for z. Z is 6 minus 3x minus 2y. Okay. Now you don't really need the picture, but I'll give it to you. So I did x, y, and z intercepts. So set y and z equal to 0 and x is 2, 2, 0, 0. Set x and z equal to 0, that gives you y is 3, 0, 3, 0. Set x and y equal to 0, you get z is 6, 0, 0, 6. So this is what it looks like. So essentially, we're finding the area of this triangle above this triangle in the xy plane, the one that goes from there to there to there, okay, which is indicated by this. But above it is this triangle. All right, so I had to analyze this. How do I get this? Instead of 0, 3, 0, I just put 0, 3. Instead of 2, 0, 0, I just put 2, 0. In other words, z is 0. And a little bit of algebra, y is -3/2 x plus 3. The y-intercept is 3. The slope is -3/2. So the surface area is the integral as y goes from 0 to -3/2 x plus 3, and x goes from 0 to 2 of radical 1 plus 9 plus 4 dy dx, 1 plus -3 squared plus -2 squared. Okay, so that's radical 14. This is constant, so it's just the length of the interval, which is -3/2 x plus 3. Okay, so that comes out to be -3/2 x squared over 2 plus 3x from 0 to 2. Plug in 0, you get 0. Plug in 2, you get, let's see, 4 cancels out 4, so -3 plus 6, 3 radical 14. 7, z equals y squared minus x squared between x squared plus y squared equals 1 and x squared plus y squared equals 4. Well, this is tailor-made to switch over the polar coordinates, right? So this is r equals 1, r equals 2. You're integrating over this region here. So r goes from 1 to 2, theta goes from 0 to 2 pi. Okay, so z sub x is -2x, z sub y is 2y. So the surface area is a double integral over the region R of radical 1 plus z sub x squared, 4x squared, plus z sub y squared, 4y squared, which is 4 times x squared plus y squared. So in polar coordinates, that's radical 1 plus 4r squared, r dr d theta. R goes from 1 to 2, theta goes from 0 to 2 pi. You can look at this. This is not affected by theta, so just take out the 2 pi, the length of the interval. The derivative of 4r squared is 8r, so multiply 8 inside and 1/8 outside, okay, to account for the chain rule. Now it works. So think of this as 1 plus 4r squared to the half. So 1 plus 4r squared to the 3/2 divided by 3/2, which means times 2/3. Okay, a double check would show me that the derivative of this should be that, right? 3/2 times 2/3 is 1. 1 plus 4r squared to the 1/2 times 8r. There it is, perfect. All right, that comes out to be pi over 6. Plug in 2, I get 17. And if I plug in 5, I get 5. I seem to be broken up here. So pi over 6, 17 radical 17 minus 5 radical 5 is what I have. Okay, it looks like it's frozen. I have to stop share and try to share again. Hopefully that'll work. And did not seem to work. Okay. So the last one I was going to do was number 8. Looks like I'll have to set up another video for that. Let me stop the share here. And try it one more time. It's not working. Okay. I'm determined to try to get this in one video. Sorry. We're having technical difficulties, I guess is what they say. So let me try it one more time. There we go. We got it. So getting back to where I was, I think I got frozen. But 17 to the 3/2 minus 5 to the 3/2. 17 radical 17 minus 5 radical 5. Remember, anything to the 3/2, it's 17 to the 1 times 17 to the half. Same thing for the 5. All right, I'm not sure where it got cut off, but I think you saw this. Okay, so finally number 8. Z equals 2/3 x to the 3/2 plus y to the 3/2, 0, 1 cross 0, 1. Z sub x is 2/3 times 3/2 is 1, so x to the 1/2 or radical x. Z sub y, for the same reason as y to the 1/2 or radical y. So I take the double integral from 0 to 1, 0 to 1 of radical 1 plus this thing squared, which is x, plus this thing squared, which is y, dy dx. All right, so this is 1 plus x plus y to the 3/2 times 2/3. Y goes from 0 to 1. Plug in 1, I have 2 plus x to the 3/2. Plug in 0, I have 1 plus x to the 3/2. Integrate that, that's 2/3, 2 plus x to the 5/2 times 2/5. 1 plus x to the 5/2 times 2/5 from 0 to 1. So I plug in 1, I get, take out the 2/5, so I have 4/15 now. 3 to the 5 halves minus 2 to the 5 halves minus, plug in 1, 2 to the 5 halves minus 1. So it's 3 to the 5 halves minus 2 to the 5 halves minus another 2 to the 5 halves is 2 times 2 to the 5 halves minus a minus 1. Okay, this comes out to be 2 to the 7 halves, 2 to the 2 over 2, 2 to the 5 over 2. So 4/15, 3 to the 5 halves minus 2 to the 7 halves plus 1. This is 3 squared times 3 to the half. This is 2 cubed times 2 to the half. So that's 9 radical 3 minus 8 radical 2 plus 1. So this is my final answer. All right. So this is section 15.5 on surface area.